And we are going to have this conference or these presentations in two parts, as you know. Professor Sefer will be hold the second one. He will be focused more on the physical part, and I am going to talk about the business part so far, if there is any. So, basically, you know, quantum computing is, as we always say, well, war is at war with quantum computing. And this is something that appeared in Bloomberg Technology. It's about putting money here, basically between two parts, which are the Chinese and the Americans, in this case. As you see here, the US was just spending about, 200 million a year. Okay, this is not the whole figure, because last year they decided just to set up some kind of conference on that, and they are going to put more money on the business. In Europe, we decide we have a flagship program with 1 billion euros. That was tremendous. But you never know, in China they decide to put about 10 billion euros. And that's without counting the money that Alibaba was directly committed to put inside the quantum computing, which was about another 10 billions, I think, 15 billions. And then Tencent, the other behemoth from China, and Baidu. You never know with the Chinese how much from this money will go to buildings and so on, and how much from this money will go to developing in quantum computer. But in any case, looks clear that in the competition there are two big players, either the Chinese. Sure, we know that in Europe it's quite complicated to look for a patent on software. This is something that is just not possible in most of the countries. And this in US and in China is different. But wherever, the figures look that they are only two big players here, which are these two ones. And there is something, we have to do something about that. So, which is the problem with, which is the idea of quantum computing? Bien, okay. In the second part of this conference, Professor will tell you about the physical points about quantum computing. But basically, I'm not going to enter here. What you are getting from a quantum computer is just a much bigger, much higher power of computation. I mean, I always like to make some comparison between quantums and classical computers. But in this case, I would like you to think it's not a perfect example, as you know, sorry, forgive me. But let's put a simple problem in a classical computing. Let's say we want to know whether you have a prime number or not a prime number. Okay? So the most basic test is about just to try to divide by 2. It doesn't work. You try to divide by 3. It doesn't work, depending you came from. You try to divide by 4 or by 5, and so on. Is there a much quicker way to do that? Okay, you put two computers. So one half of the numbers go through one computer, another half of the numbers go through the second computer. Are there some other ways to do that much better? Yes, you put more and more computers. What quantum computing is a kind of this parallelism. It's not so perfect, but it's kind of using instantly a very huge number of possible computers. Okay, so the problem, you can just try to do that, not immediately, but quite fast. For sure, this is not a perfect analogy because you cannot access all the solutions. There are some caveats, there are some problems in just trying to get the correct solution, but this is the idea. So, just supposing that this is, no, okay, just to put a clear example about that, this is a machine from Natos, which is a very huge European company. This is not a quantum computing. A quantum computer. This is only a simulator of a quantum computer, and these machines came from 2017. Okay, the most powerful one, just to simulate a quantum computer, requires as much as 24 terabytes of memory, while simulating only a quantum computer, we'll see later, of only 40 qubits. Okay, now we are talking about 50 qubits. So that means that there is, at some point, we have not a classical, a traditional computer that can do the same things as a quantum computer. So, but we can see that the so largest requirements of a classical computer just to perform as a quantum computer. So, what that will be in the future? First of all, and this all, we are just entering in the part of the business, cryptography, for sure, when we have a quantum computer powerful enough, which means that we will have about 1,500 qubits, cryptography will be gone. This is the first thing that we'll notice. There is a thing that is quite important, that there is a special way of cryptography, which is not the RSA, but is the elliptic curves, that this is cryptography is using the blockchain business. That means that probably the blockchain will fall earlier than the rest of the cryptography, because, okay, it's easier. Okay, guess which are the affected fields? Nearly everything, from the banking, from finance, which we are talking about, and from any kind of communications, telecoms, and so on. And for sure, this is a field that in industry that we have some startups working here. And some of the startups has been backed by Barclays and some other banks. So this is a business itself. For sure, let me again, here. There are some other fields that are affected, but, excuse me, okay, here. I don't know whether I'm going just backwards in time or okay, yes, please, you may help me. No, again, yes. But now, yes, again, just, wasn't it about finance? So let's talk about the possibilities of quantum computing in finance so far. So I will just refuse to use, that doesn't mean, thank you very much. If you can just pass me the thing. Can you go another one? So I am going to put here 4 possibilities. These are real possibilities of doing things or to start doing things in quantum computing and finance. So all these 4 possibilities came from papers that have been published in some journals. So the first paper is about trading. So for you to know, the biggest, the name of the game in finance for the quantum computer are basically optimization. Okay? Optimization is what the quantum computers can do very well in some fields of finance. Okay? So the first thing is the optimal trading, which is basically you are going to buy or sell large quantities of assets in the market. This is something that the traders do. If you try to do immediately, you are going to modify the prices. If you put a lot of assets to sell in a particular moment of time, the prices are going to behave differently from what you expect. So what you have to do is just to sell the assets very slowly. But the slower you sell the assets, the more critical it becomes to you, because prices may vary, may change because of some different reasons. So there is an optimal way to do that. And there is some paper stating how can you use these quantum computers just to do that. The second paper is about the arbitrages. Again, it's an optimization. Again, you have a lot of assets, and you have to just to perform or to build a very good or nearly perfect portfolio, balancing usually risk, profitability, and so on. Problem is with classical computers that the most assets you have, the most difficult to get an optimal portfolio is. Again, you have a paper here. Thank you very much. Credit scoring, which is, we are just entering in artificial intelligence, and credit scoring is about basically, detecting the optimal feature selection for this kind of things. There is again some tests on doing that. With quantum computers, I mean, these are things that the classical computers are already performing, but quantum computers can also do. And for sure, the final about artificial intelligence and so on. Artificial intelligence, in some cases, in deep learning and this kind of fields, you can see that as an optimization problem. You have a network, you have a neural network, and you have to optimize the weights, the connections between the different components of the network. Okay, once you see that this may be an optimization problem, you can apply or to try to apply a quantum computer to do that. Exactly. And finally, I have put another one which is different. This is about risk. This is not optimization. The 4 previous problems were about optimization. This one is about simulation. And this is about the simulation of risk. This is the most used way to simulate the behavior of a financial instrument is the Monte Carlo simulation. Monte Carlo simulation is only just to perform a lot of possible simulations and then try to get the final distribution of the outcomes. So you can use that. You can try to do that with a quantum computer in a much faster way. So this risk simulation leads directly to the pricing of some financial instruments. So this is also a very good place for the quantum computers to enter. For sure, another question. And finally, just for you to know, there is another way to use, in the future, to use the quantum computers. It's about not finance, but economy. And this is a different game. So the point is, this was the subject of a presentation from the European Bank in Barcelona in the last mobile, very short. Okay, as you know, we have some macroeconomic models of the economy. The problem with macroeconomic models is that you may design any kind of macroeconomic or the macroeconomy model, but just making some computation with these models are just too complicated. So you have to use simplified models. And then you apply some financial, fiscal, and financial economy tools. You decide to rise the interest rates, lower the interest rates, rise the fiscal impact or whatever, and then you expect the economy to behave in some way. Okay, nowadays we don't have any tool to simulate the whole economy. Okay, there have just begun to appear some models that try to put economy or simplify, to put a model of the economy and just to compute these, which are the outcomes of some macroeconomic policies. Okay, so this is another way where the quantum computers may apply their power in the future. So, okay, for sure, there are much more things like that. This is not in finance. This is, corresponds to a real project from Volkswagen trying to perform the optimal distribution of the traffic in some cities. According to Volkswagen, this was China. The skies are blue, so it's not so China, but anyway, could be. Okay. Or to life science, there are some startups working in life science, basically applying artificial intelligence pass through the quantum computers just to perform a much quicker discovery. Or, for example, we have already talked about the artificial intelligence and so on. Okay, said that, The problem is, well, there are some very not so small problems. Okay, first of all is that, okay, we have quantum computers of about 50 qubits, but we need about 1,500. And this is not a small thing, because this is not an engineering, no, come back please. This is a very big problem. Second, the quantum computers are quite, as you see later, are quite sensible. So you can use only the quantum computer for a very short time, which is the coherence time, which allows you or limits the size, the total size of the program you may run in a quantum computer. Even worse, there are a lot of errors, so you have to correct the errors, and correcting the errors may require multiply by 1,000 the qubits and so on. And finally, algorithms are quite different from the classical classical computers. So these kind of algorithms are basically mathematical algorithms, and managing these algorithms may be complicated, please. So, according to Gartner, quantum computers is just arriving to the highest point of the hype. So we are just expecting a winter quantum computer in quantum computer. So in the following, let's say, 2 years or so on, people are expecting that quantum computers, interest in quantum computers will be maybe lower, but then rise again. Well, the point is there are appearing more and more and more companies just in quantum computers. There are all these ones which are big names, but there are also some small names. And the money that you need to start a quantum computer company is not so big. This is, for example, one of the best known quantum computers, which is Righetti Computing. And Righetti Computing, which is one of the very few one in the United States that are manufacturing quantum computers, they only need to raise about $70 million. For you to know, a regular quantum computer from D-Wave costs about 15 million, and a supercomputer, a classical supercomputer, may go to the hundreds of millions. Not a quantum, a classical supercomputer costs hundreds of millions. So, for sure, we have some companies in Europe. We were just talking about some of them in finance. We have Talent. This was a very good company, European company that now belongs to a South Korean telecom, for example. And if you want, some of you want to play, for sure, probably you will know, but there you have all the simulators online. So if you want to play with the IBM quantum computer, you may go to Quantum Experience. If you want to play with Righetti, you may go to Forest. It's open. Or even the Japanese, this is an annealer. We will explain later the annealer. You can get free access to these quantum computers. So there are more things about that not only quantum computer. We have what is called a quantum manifesto, in which states which are the expectations of the things to develop. We have quantum mechanics and quantum technology affects communication to secure the communication. This is a technology that has already arrived, especially if you are using cable, not multi-stage connections. Simulators, this is something that is applied specifically in chemistry. Sensors, we have already companies that are developing quantum sensors. This is a mature or nearly mature field. And finally, the quantum computing that will take somewhere from 5 to 10 years or even more to develop in full, just to overcome the problems that we have seen before. Some expectation, probably you will talk about later because I have in this one, has run short in communications. And some others, this came from a report from Accenture and 1Qubit about what to do for a company in quantum computing. That means today just you have to begin to prepare yourself for doing that, because when it arrives, probably it's going to change everything. And well, finally, a word about us. We are the Quantum World Association based in Barcelona, founded in Geneva, and so on. And we have just are trying to connect everything from the business side and the technical side. I think that's for, we are also that. And please, yes, thank you very much. That's all. I don't know how much time I have. Just this, that. So, please, Professor. Oh. Yes, we can start with the questions now or maybe later. Maybe now, prefer? Okay, some questions. Okay, if you have some questions later or whatever, you may ask anyway. Thank you very much.
A question about this project Volkswagen and Google. Why did they choose
China. We don't know. We don't really know why did they choose. People say that what they tried to do was a totally different thing. They choose China, whatever the reason, but the point about Google and quantum computing and traffic is that car companies are changing themselves from a manufacturer to an operator of fleets of cars. I mean, I don't know whether you have in Turkey here, probably you have, but you can hire. I mean, these companies are expecting not to sell the cars, but to hire the cars and to use only on a temporary basis. That means that they have to perform or they have to compute which is the best distribution of the cars in a city for these kind of things. Okay, this is what the insiders said that they were looking for. Why they choose China, I don't know. I mean, it wasn't the first place I will choose, because probably the Chinese have their own way to do these kind of things. But this is, for sure, they have also run a second project, but much lower one, in Barcelona. I mean, exactly the same. But you cannot compare Barcelona with Beijing, that's for sure. I mean, we are just too small. Yes.
Where are you seeing the majority of activity and then the investment landscape?
Yes. Okay. When I see the most of the activity is in the software providers at this moment. So software providers are just basically two kind of companies. One of them used to operate the D-Wave computers. D-Wave, for you to know, there are two big. It's a risk of simplifying the things. There are two big families of quantum computers. The full-fledged quantum computers like Righetti, IBM, and this one, that you can do very few things with them, but for sure in the future belongs to this kind of companies and this kind of computers. These are the quantum computers that could do everything. So there are some companies that working with this kind of things, preparing algorithms that you cannot apply in full today, but probably you are going to apply in the future. The second one is the D-Wave, which are the annealers. Annealers is a kind of quantum computer that is not a very good quantum computer. Some people say they are not even quantum computers somehow. You have some papers. But they can do only one thing. But they do this thing very well, which is optimization. So you can perform an optimization in some computers like that. And if you choose the problem very good, you can apply this solution in the short term, because for example, an IBM is about 50 qubits, and D-Wave now is the last one they have is about 5,000 qubits. They cannot do the same. They only can do optimization, but this is good enough for doing that things. So there are some companies in software working with this field. Apart from that, there are some other companies, a very small number of companies working with hardware. For example, Righetti is a well-known example. There is another company funded by the European flagship, which is most of them, as far as I know, is based on the developments in Austria. And this kind, they have a quantum computer, they develop a quantum computer based in what is called ion traps, and they think that they can make evolution this computer on the higher part. But most of the movement, as far as I know, is located in software and mainly not in annealers, but in the other one. For example, Entropical Labs. Entropical Labs is from life science, and they are doing in full-fledged quantum computers. For example, the nice name there, or the biggest name there, which is Zapata Computing, which also came from the US. They started from chemistry. In fact, the CEO and the founder is a chemistry from Harvard and now MIT. But they are trying to evolve to some other parts. There are older names as One Qubit. This is a consultancy firm like now, and this is a kind of software and something like that. Strangeworks. Strangeworks is a kind of different thing. They came also from the United States, and they are just in the business not of performing algorithms, but to providing platforms to use the different kinds of quantum computers. And some other names will be the same. In the case of financial or finance or quantitative finance companies, in the United States, there are some companies trying to do that, but in Europe, we have at least two. One is GOS, and the other one is Multiverse. I am related to Multiverse, so please take that. But there are two. Okay.